gonna discuss on binomial theorem, right? So in module the class it is like class discussion questions. Okay, so let's go. So the coefficient of the first question is the coefficient of x to the power 100 in the expansion of this. Okay, so the question is like this: r 0 to 200 1 plus x to the power r. So I have to find the coefficient of x to the power 100. Okay, so what we can do is so there is a direct formula for this actually, right? So please make a note of this. Summation from r to 0 to n 1 plus x to the power r, the limit is on r, is actually equals to n plus 1 c. If you want to find the coefficient of x to the power r in this particular expansion. Okay, so the coefficient is this x n plus 1 bracket में r plus 1, right? So n plus 1 and r c r plus 1. So for this it is simply going to be how can you write? The n is 2, so 201 c. What is r? We have to find the coefficient of x to the power 100. Okay, so that is going to be r. R is this is r, so this is going to be 100 plus 1, so 201 c 101. Okay, so this is how you can do this. If you want to examine this whether it is true or not, you simply take this 1 plus x to the whole power r, and summation is on r to the power 0 to, let's say, for 3, because till 3 you can easily find that. Okay, so and try to find the coefficient of x square. So for here it should be n is 3, so 3 plus 1 4c. If you want the coefficient of 2 3, so it should be 4c3, which is 4. And now expand this. What is going to be? We want to calculate the coefficient of x square. So what we can do, 1 plus x to the power 0. So here we are not going to get x square, so there will be no coefficient. So 1 plus x to the power 1. Here also we don't have any term of x square, so I will not get any coefficient from here. And from here onward, 1 plus x square. Here the possibility is there, that means in the expansion 1 plus x square, there is x square. Okay, so x square, the coefficient of x square from here is 1, and from the 1 plus x to the power 3, this can be written as 1 plus x cube plus 3x square plus x 3x. Okay, so the coefficient is going to be 3 plus 1 4, so that is correct. So this is how you can calculate. Means in exam, if you forget the formula, then this is how you can do this. Okay, now next question, second. The question is the coefficient of x to the power r in the expansion of this. Okay, so we need to calculate this. Okay, so if you observe the series, it is in GP. Okay, so it is something like this: x plus 2 to the power n minus 1 and plus x plus 2 to the power n minus 2 and x plus 1 and so on, right? So this is going to be x plus 1 to the power n minus 1. So this is a series, and if I have not written it directly, means the next term after this, so you can directly find that this is GP, whose first term is x plus 2 to the power n minus 1. So a is equals to x plus 2 to the power n minus 1, and this is and common ratio is, if you divide this by this, so it is going to be x plus 1 upon x plus 2, yes, it is r, right? So if this is s, then s can be written as this. First term is x plus 2 to the power n minus 1 and r to the power n. So what is r? R is this. So x plus 1 upon x plus 2 to the whole power n minus 1 upon r minus 1. So r minus 1, this is r to the power n minus 1 upon r minus 1. So what is r? R is x plus 1 upon x plus 2 minus 1. So you know that the formula a r to the power n minus 1 upon n minus 1. Okay, then how will you know that how many terms are there? See here, there is x plus 1 to the power 0, right? And it is starting from x plus 1 to the power 0 and it is going till n minus 1. So there is n terms in total. Okay, that is why we are putting r to the power n here. So if you solve them, so what we are going to get, x plus 2 to the power n minus 1, and here you can write it like this, x plus 1 to the power n minus x plus 2 to the power n, this whole term divided by x plus 2 to the power n, and this thing is divided by this, so x plus 1 minus x plus 2 upon x plus 2, right? So I guess this n will cancel out with this, so it is going to be just minus 1, and okay, so this x will cancel out with this, so 1 minus 2. So after simplification, this should be what it is. Alright, so x plus 2, and this x plus 2 will cancel out with this because it is minus 1. You will simplify and you will get that this is how it is. So x plus 1 to the power n minus x plus 2 to the power n upon minus 1. 1 minus 2 is minus 1. So this is what we get, right? So in this in this particular expression, we have to find the coefficient of x to the power r. Okay, so we have to find the coefficient of x to the power r. So let's say so this can be written as, so this term can be written as x plus 2 to the power n minus x plus 1 to the power n, right? So for first x plus 2 to the power n, so the general term is t, let's say ts plus 1, the general term, let's say ts plus 1. Okay, so it is going to be ncs and x to the power s and 2 to the power, okay. Alright, so x to the power n minus s and 2 to the power s. Remember that it is s. Okay, now we are interested to find the power of x should be r. Okay, so the power of, so n minus s should be r. So what is s is? S is n minus r. So s becomes n minus r. Hence, in order to get the coefficient of x to the power r, you have to put n minus s equals to r. This is a general method. So if n minus s is r, then we are going to get the coefficient. So we have to substitute, for that we have to substitute the value of s as n minus r. So t n minus r plus 1th term will have ncs, and what is s? S is n minus r, and x to the power r and 2 to the power s, and what is s? S is n minus r. So the coefficient is this, right? So nc n minus r into 2 to the power n minus r is the coefficient of x to the power r in this particular term, not this, in this particular term, right? So similarly, if you calculate again, right, for x plus 1 also, okay, so you have to do the same for x plus 1 also. So I'm gonna show you t, let's say again s plus 1 is like this, nc s and x to the power n minus s, and as 1 to the power anything will become 1, so I am not considering it for now. And now substitute n minus s equals to r, because we are interested to find the coefficient of x to the power r. So if n minus s is r, then it will become x to the power r and we will get the coefficients, right? So just substitute s equals to n minus r. Okay, so s equals to n minus r. So nc n minus r x to the power r, and this will be vanished because 1 to the power anything is 1. So this will become t n r plus 1. So this will be the coefficient in this case. Okay, so nc n minus r is the coefficient. Now we have to subtract them because we are interested to find the coefficient of x to the power r only. Okay, so from here, from this term, please pay attention, x plus 2 to the power n, the coefficient of x to the power r is this, 2 to the power n minus r into, okay, I think I should write it separately. Okay, so I'm just removing this from here. So this becomes x plus 2 to the power n minus x plus 1 to the power n. In this, the coefficient of x to the power r in the expansion of x plus 2 to the power n is this, 2 to the power n minus r into nc n minus r. And for the other one, what it is nc n minus r. So minus nc n minus r. Okay, so if I take nc n minus r as a common, so the answer is 2 minus r minus 1. 2 to the power n minus r minus 1. Okay, so okay, oh okay, you know that nc n minus r is equals to ncr, right? So both are equal. If you expand this one, so this is going to be n factorial upon n minus r factorial upon n minus n plus r factorial, right? This will cancel out, so r factorial will remain, which is exactly same. So these are equivalent. That is why you can write it like this thing, ncr 2 to the power n minus r minus 1. So this is how you have to do this. Okay, so all right, now so this is how you can do this. Now the next question is question number 3. So please make note of it. Okay. So the next question is the greatest value of terms independent of x in this expansion of this. Okay, so x sine alpha plus x inverse cos alpha to the power 10. So we are interested to find the greatest value of the term which is independent of x. Okay, so what would be the maximum value in the expansion of this which is independent of x. Okay, so let's say we find that tr plus 1th term is the independent of anything, right? So this is how you can write it. So this can be ncr. So ncr, and this is x sine alpha to the power n minus r and x inverse cos alpha to the power r. So this is going to be ncr x to the power n minus r, and this can be written as sine alpha to the power n minus r, and again this can be written as x minus r into cos alpha to the power r. Okay, after separating them, so ncr, this is going to be sine alpha to the power n minus r, this is going to be cos alpha to the power r, and after combining these two, I am going to get x to the power n minus 2r. Okay, now n minus 2r is equals to 0. Why? Because we are interested to find the term that is independent of x, and this term will be independent of x if n minus 2r equals to 0. So that is why r is going to be n by 2. Okay, so the term which is independent of x is t n by 2 plus 1th term, right? And that term become nc n minus 2 sine alpha to the power n minus n by 2. What it is? N minus 2. N minus n by 2 is n by 2. Now cos alpha, and cos alpha is n by 2. So this can be written as this is the term which is independent of x, right? So this can be written as sin alpha cos alpha to the whole power n by 2, right? Now we are interested to find the maximum value. So what you can do is in this multiply and divide by 2 like this, nc n minus 2 n by 2 2 into sin alpha cos alpha divided by 2 to the power n by 2, right? This is how you can write it. Now so if I take this denominator 2 outside the bracket, so it is going to be like this. Okay, and this will become sin 2 alpha to the power n by 2, and you know that the maximum value of sin alpha is 1, right? So the maximum value of the coefficient will be nc2 upon 2 to the power nc n by 2, nc n by 2, right? 2 to the power n by 2. So here n is 10, so this will be, because n is 10, so this will become 10c5 and into 1 upon 2 to the power 5, and if you substitute the values, it will become, I guess, 10 factorial upon 5 factorial upon 5 factorial into 2 to the power 5. So 10 factorial upon 5 factorial is into 5. So C must be the answer. Okay, so this is how you can do the question number 3rd. So the next question is question number 4. Now the coefficient of the middle term in the expansion of this and this is same, then find the value of alpha. So the two terms are 1 plus alpha x to the power 4, and the other one is 1 minus alpha x to the power 6, and they are saying that the coefficient of the middle term. So how many term will be there in the expansion of this? 5, and here it is 7. So if the total number of terms is in the expansion, if the number of terms is odd, then there is only one middle term, and which is t. So there will be 5 term in total. So the term will be 5 plus 1 divided by 2. This term will be the middle term, right? And for here there will be total 7 terms. So 7 plus 1 divided by 2 will be the middle term. So it is going to be 5 plus 1 6 3. What it is? 3. So t3, and t3 can be written as t2 plus 1. And for here it can be written as 7 plus 1 8 t4, right? So the fourth term will be the middle term, and this can be written as 3 plus 1. If I calculate this, so this is going to be 4n for here, 4c 2, 1 to the power 4 minus 2 is 2, and alpha x to the power 2, right? So this will be the third term for this expansion, right? This will be the third term, and for here it is going to be t3 plus 1, which is 4, which will be 6c3, 1 to the power 3, and minus alpha x to the power 3 also, right? So this is going to be 6 minus 3 is 3 to the power 3. Yes. Okay, so this is how you can do this. Now we are saying that these two coefficients are same, right? The coefficient of the middle term in the expansion of is the same. So the coefficients are same. So 4c2 1 to the power 2 is same. So this can be written as alpha square. The coefficient is going to be this, right? Coefficient means everything except x, the term x, right? And from here it is going to be 6c3. 1 to the power 3 is 1, and minus alpha to the power 3, right? So minus alpha to the power 3 can be written as like this. So alpha square will cancel out with this, and 4c2 I guess 6, 4 3 2, yes. Now, and this is minus, I think 15, right? 6 into 5 into 4, 6 5 4 upon 3 by 26, 5 for the 20, yes. So alpha is going to be 6 by 20 with minus 5. So the answer should be 3 by 10. Yes, minus 3 by 10 is the answer, right? So this is how you can do this. Now next question, question number 5. So this was question number 4, and the coming one is 5th. So the 5th question is, in the expansion of this, the coefficient of x to the power k is, okay. So if you look at the question is something like this: summation 1 plus x to the power n, 1 plus x to the power, let's say it r as 0 to what, n, right? So if you generalize the series, so it is something like this: 1 plus x to the power r, and limit on r is from 0 to n on the summation, right? So it is going to be like this. So we are interested to find the coefficient of x to the power k. So in this we have to find coefficient of x to the power r. So we are done with this question in first question, right? So it is very similar to question number 1. So the answer is n plus 1 upon c k plus 1. So you have to remember it as a formula also, right? So please, okay, so you have to remember this. So n plus 1 c, I think it is k, or yes, it is k. It should be k. Okay, so this will be your answer. So you have to remember this. Now the question number 6. So the question number 6 is like this: t naught, t1, this. So in the expansion of x plus a to the power n, how can I write it? nc0 x to the power n, nc1 x to the power n minus 1 a, plus nc2 x to the power n minus 2 a2, plus and so on, ncn and a to the power n. So they are saying that this is your t naught, this is your t1, and this is your t2, and so on, this is your tn. So this is what they mean, right? And we are interested to find the value of t naught. This. Okay. So if you look at the question, at the options, so you can see that on the basis of the question that has been asked, it is better if you put if you substitute the value. So substituting the value is more effective than solving it by long way or general way like this. If you put n equals to, let's say for the sake of simplicity, let's put n equals to 2. If I put n equals to 2, so it is going to be this, right? And it will be x square plus 2xa plus a square, right? So this will become t naught, this will be t1, and this will be t2, right? Now according to them, it will be t2 minus t2 times square minus plus t1 to the power 2, because there is no t3, right? So that is why we have to restrict ourselves at t1 only, right? If it is x plus a to the power q, then there will be t3 also. Then it will remain as t2, t naught minus t2, because there is no t4 or and so on anything. So that is t naught minus t2, and here it will becomes t1 minus t3 in case x plus a to the power cube. If you substituted that n equals to 3, okay? So like this. Now what is t naught? T naught is x square. So x square minus a square plus t1. And what is t1? 2xa to the power 2. So if you solve them, so what you are going to get? X square plus, sorry, x to the power 4, a to the power 4 minus 2x square a square plus 4x square a square, right? So this minus and this plus will cancel out and it will become plus. So that is going to be, okay, so right. So I am reading it for you. X to the power 4 plus a to the power 4 minus 2x square a square, and here it is going to be 4x square a square. So it is going to be, so from here it is going to be x to the power 4 plus a to the power 4 plus 2x square a square, which is equivalent to x square plus a square to the power 2, right? So if I compare this thing with the options, so we are going to get only the second option is matching, right? So that is why the answer should be option number B. Okay, so if we want to solve it by the actual method, so it is going to take about a lot of time, right? So you can do it like this. Okay, this type of question is done with means like that way, like this way. Okay, because most of the student leave the question by looking it. Okay, so it is not so hard, but you have to just take it efficiently. Okay, so this is how you can do this. So the next question is question number 7. The greatest integer which divides the number this. So 101 divided to the power 100 minus 1. So we have to find the greatest integer which divides this from the options, right? So you can write it like this: 100 plus 1 to the power 100 minus 1, and expand this. So 100 is 0, x to the power 100, and 1 to the power 0. And x is 100 actually, right? So or you can write it like this: 1 plus 100. Just means you can do it by this way also, but by this way it will be a little bit easier, right, to understand. So just follow me. Now it is going to be 100 C0, first 1 to the power 100 and 100 to the power 0, right, plus 100 C1 and 1 to the power 99 and 100 to the power 1, plus 100 C2 and 1 to the power 98, so I am not mentioning it, 100 square, plus and so on, 100 C100 and just it is, okay, and this thing minus 1, right, this minus 1. Now if you see, look at here, so 100 C0 is 1, this is 1, this is 1, right, this term is 1, so there should be 100 to the power 100, 100 to the power 100, right, minus 1, okay, so here it is 1 and here 100 C1 is 100 and it is 100 also, right, so you are getting this, see 100, this term is 1, this term is 100 C1 into 100, right, so this is going to be 10,000 and it is 100 C2 into 100 to the power 2, right, so this one and this one will cancel out because it is minus 1 and it is plus 1, so what will remain there, 100 C1 and into 100 plus 100 C2 into 100 to the power 2 plus 100 C3 and 100 to the power 3 plus and so on 100 C100 and 100 to the power 100, right, so this is how you can get it. Now they are saying that which is the maximum value from which you can divide it, right, so if you look at this term is common among all, right, because it is 100 C1 is 100 into 100 which is 100 square, right, so 100 square is common among all, right, so the maximum term that you can take common from this expression is going to be 100 square, right, so which is 10,000, so 10,000 is the maximum integer that can be divided, right, so you cannot divide anything further because you cannot take common like any greatest value more than 10,000 which will divide it, okay, you cannot take a common from this expression, so that is why the answer should be 10,000. So the next question is 8, right, so the question is 1 plus x to the power m x is minus 1 upon 8x square, okay, so if the third term in the binomial expression of this, then the rational value of m, okay, so they are saying that rational value of this, okay, you can explain it by, as you know, in usual way, but as they are saying that m is a rational value, right, so it could be fraction also, okay, so the binomial theorem is not applicable here, so you have to write it like this way, 1 plus x to the power m or n, it is, so I have there is a formula for this, I have mentioned that formula in last class, so you can write it like this, 1 plus mx plus m into m minus 1 upon 2 factorial x square plus m into m minus 1 into m minus 2 upon 3 factorial into x cube and so on, right, so this is the formula, it goes till infinity, so if m is a rational number, so they are giving a hint, right, so m is a rational, so m could be a fraction also, okay, so they are not saying that it is integer. For binomial theorem it is important to have n as an integer in the x plus y to the power n, okay, so 1 plus x to the power m is a rational, so it could be positive, it could be negative, it could be fraction, right, so if m is any of this, means if it is fractional value, it is a negative value, then this formula can be used. Now they are saying that if the third term in the binomial expansion, so first, second, third term is this, okay, then find the value of m, I guess, so x square is equals to minus, means m into m minus 1 upon 2 factorial is 2 into x square, so x square will cancel out with this, 2 4s are 8, so minus 1 by 4 is equals to m into m minus 1, so if you will have to substitute the value of m, So I guess 1 by 2, 1 by 2 into 1 by 2 minus 1 is minus 1 by 2, so m should be 1 by 2. So that is the answer, right? Next is question number 9. So the first three terms in the expansion of this, where n is not equals to 0, are this. Then the value of a and n respectively, right? So there is no indication like it could be rational or something like this. So that is why you have to expand it by binomial approach, right? So this can be written as 1 plus ax to the power n, right? So if I expand it, it is going to be nc 0 and ax to the power 0 also, plus nc1, and it is going to be ax, plus nc2, it is going to be ax square, plus and so on, right, till ncn. Okay, and into ax to the power n also, x to the power n. Okay, now the first three terms are this. Okay, so the first term is 1. Okay, so it is not useful because we are not doing anything, getting anything from here. And the second term is 6x. So second term is this. According to question, nc1 into ax is 6x. So x will cancel out with this. nc1, what is nc1? n into a is 6. So remember this. Now in the second expression, the second expression is a 16x square, means the third term is 16x square. This is 16x square. So what you can do, nc2 means n into n minus 1 divided by 2, a square x square is equals to 16x square. Got it? So this is how you can write it. 1 16x square, yes. So x square will cancel out with this, and this is going to be n into n minus 1 into a square is equals to 32, right? Now you can try it like this. Okay, otherwise you have to put n equals to. So sometimes the questions are in solving the questions, the calculation part becomes a little bit tricky. Okay, so pay attention over here. So generally what students do, they take the value of n here and substitute it over here, and the calculation becomes tedious, right? So what you can do, you can separate it like this. This a into n, because you know the value of n into a. Okay, so this can be written as n into a and an minus a. Okay, so a into n becomes this, and a goes inside, so it becomes an minus a. So what is the value of na? 6. What is the value of an? 6. Now 6 will go here, and it will become, I guess, 32 by 6. So okay, so please you write it in the form, in the correct form, right? So if you take it over here, so this is going to be 6 minus a is equals to 32 minus 6, which is 16 by 3. So what is a? A is going to be 6 minus 16 by 3. So what could be the possible value of a? A is 3 6 18 minus 16 is 2 by 3. So the value of a is 2 by 3, and by looking this, you can get the value as option C. So you can substitute the value of a, and you can get the value of that also, right? So this is how you have to do. This was the question number 9. Okay. All right. So the next question is question number 10. So they are saying that if the coefficient of p and p plus 1 and q p plus 2, means coefficient of, this is the question number 10, coefficient of p and p plus 1th and p plus 2th, this is p plus 2th term is in AP, right? So we have to prove something, right? So means there is some equations given in option, and you have to check which one is true, right? So in the expansion of 1 plus x to the power n, so p can be written as p minus 1 plus 1. So this can be written as nc p minus 1 and x to the power p minus 1, and the coefficient will be nc p minus 1, right? The coefficient is the constant portion, except the means leaving the variable, right? And p plus 1 is going to be ncp x to the power p. So this is the coefficient, and p plus 2 can be written as p plus 1 plus 1, right? This is p plus 2. This is how it can be written as. So ncp plus 1 and x to the power p plus 1. So this is the coefficient, right? So we have to check which equation holds on, right? So because these three terms are in AP, this is the first term, second term, third term, and it is in AP, then the average of the means the middle term is the double of the sum of the remaining two, right? So this can be written as 2 into NCP is equals to NCP minus 1 plus NCP plus 1, right? So if you expand it, so this is going to be n factorial upon p factorial, and here it is n minus p factorial. Okay, so this is going to be n factorial upon p minus 1 factorial, and this is going to be n minus p plus 1 factorial. You can solve it, right? N factorial upon p plus 1 factorial, and this is going to be n minus p minus 1 factorial. Okay, so this will cancel out, and the next thing, take common as per here, right? So what you can take common, right? So it is in factorials you can take common, this term has a larger value, right? You can take a smaller value as a common from the larger one. So if I see this and this, p minus 1 and p plus 1, so p plus 1 is largest, right? So the largest should be expanded, and minimum means the lesser one should be taken as a common. So I am taking p minus 1 as a common, right? In these two, which one is lesser? This one is less, right? N minus p plus 1 and n minus p minus 1. So this one is lesser, so it should be taken as common. So it is going to be n minus p minus 1 factorial. And here what we remain with 1 upon p minus 1 factorial is common as a whole. So what is remaining? Okay, p minus 1 factorial is common as a whole, right? And this can be expanded as like this, n minus p plus 1. I think I should expand it also. So this is going to be 2 into 1 upon p into p minus 1 factorial, and this can be written as n minus p minus 1 factorial, n minus p into n minus p minus 1 factorial. Okay, and now this can be written as 1 upon p minus 1 factorial, and this can be written n minus p plus 1 and n minus p and n minus p minus 1 factorial plus 1 upon p plus 1 factorial, p plus 1 into p minus 1, and this can be written as into p minus 1 factorial. It is p plus 1 into p minus 1, and this is as it is, n minus p minus 1 factorial. Okay, so it is become a little bit lengthy, so please pay attention. What we have done is, so first of all take these two, right? P minus 1 and p plus 1, they are like terms, means p plus 1 factorial contains this, right? So which one is lesser? This one is lesser, so this should be kept as it is, and the other one, which is the larger one, it should be expanded. So I have expanded it, p plus 1 into p minus 1 factorial. You know that, right? A factorial can be written as a into a minus 1 factorial, or this can be written as a into a minus 1 into a minus 2 factorial, right? So this is what I have used. So p plus 1 into p minus 1 factorial. Okay, so this has been expanded. Now in these two, which one is larger? So this one is larger, so this should be expanded. So n minus p plus 1 into np into n minus p minus 1. Always take minimum. Go till minimum, right? So n minus p minus 1 factorial, and here because this one is the minimum, so it has to be left as it is, right? Now see what maximum term that you can take as a common, right? And expand the left hand side accordingly, right? Here we have p minus 1 what we have common, p minus 1 factorial as a common, right? Here and here, so I have to expand it till p minus 1 factorial, and also we have common n minus p minus 1 factorial from these two, so I have expanded n minus p till n minus p minus 1 factorial. So n minus p into n minus p minus 1, so p minus 1 factorial, n minus p minus 1 factorial will cancel out, p minus 1 factorial from here and here, and n minus p minus 1 factorial from here and here, and the expression becomes like this: 2 upon p into p minus 1, p into n minus p n minus p, right? And the other one becomes is equals to 1 upon n minus p plus 1 into n minus p. Okay, and okay, so what it is p plus 1 factorial. So here it is not in the shown now, and this side it becomes plus 1 upon p into p plus 1, p into p plus 1. So from now it is just a calculation part. So let's do this. How can I do this? 2n minus p. So you can write like this. You take cross multiplication and take it from that side. Now p, it will become like this: p into n minus p upon n minus p plus 1 into n minus p, and here it will be p into n minus p upon p into p plus 1, right? P, and n minus p is n minus p. Okay, now just add them and do cross multiplication. So I'm doing it directly. You please go step by step in order to understand, right? You have to add them. So n minus p plus 1 into p plus 1, this will cancel out and this will go here, p into p plus 1, and plus p plus 1 will cancel out, n minus p into n minus p plus 1, right? This is the value. Okay, so please note it till here. Okay, so here you go. Now take the cross multiplication and it will become 2 and n minus p plus 1 into p plus 1, and from this on this side you do multiplication, p square plus p, and here it is n square plus p square minus 2np and plus n minus p. Okay, so this is what you will get after multiplication, right? So p will cancel, p is going to be cancelled out with this, and here also we have to multiply, right? So this should be like this: 2pn minus 2p square plus 2p, and then plus 2n minus 2p plus 2. So this should be equals to p square plus p square 2p square, n square plus n, p square n square plus n, 2p square n square plus n minus 2np. Okay, so please don't mess up with this. Okay, now 2p square and 2p square, so what you can do, anything cancel, 2np, 2np there. Okay, just take all these things over here to there. Now 2p square and 2p square, 4p square. Okay, and if there is any square, and 2np and 2np, it will go there and it will become 4np, so minus 4np, and this is 10p. Alright, so so 4p square minus 4np, will cancel out with this, 2p will cancel out, 2n plus 2, and this will just check it over, check here again. After multiplication, this should be from here, p square plus p, this will 2, this is going to be n square n minus p. So n square plus p square minus 2np, and this will multiply and become n minus p. Alright, so these two is cancel out and this will go there, so it is going to be minus n minus 2 equals to 0. 2n, this 2n go there and it will become minus n, and there is n square plus n square also, plus n square this one, minus 2 is equals to 0. So let's do now n square, so I have to take n square as a common. So none of the questions are going to match, right? So 4p square we have as an option, so n square, and from here take minus n as a common, so it is going to be, if you take minus n as a common, so it is going to be plus 1 and plus 4p, right? And it is going to be minus 2 plus 4p square equals to 0. I guess none of them is matching, right? N square minus n, 4p plus 1 plus 4p square minus 2, yes, the second one, b, right? So n into 4p plus 1. Yes, so the option D is the correct answer. So in this type of question you have to be very careful with the calculation parts, right? So they are easy, but the calculation part becomes so lengthy. Okay, so this is how you can do this. So the next question is question number 11. So the coefficient of x to the power 32 in the expansion of this, right? So in the expansion of x to the power 4 minus 1 upon x cube to the power 15, you are supposed to find the coefficient of x to the power 32. So let's say pr plus 1 is the term which will contain x to the power 32, and so we will get the coefficient, right? So pr plus 1 will become ncr, and x to the power 4 to the power n minus r, which is 15 minus, so it will be 15 because n, this is n, so 15 minus r and minus 1 upon x cube to the power r. So this is going to be 15 cr, x to the power, if you multiply them, this is going to be 16 minus 4r, and this will become I can write it like this, minus 1 to the power r and x to the power minus 3 to the power r. Okay, so this is how you can write it, minus 1 into this, and the power will be distributed. So 15 cr minus 1 to the power r, and this can be written as x to the power 60 minus 4r minus 3r, right? So x to the power minus 3r into this minus 3r, x to the power minus 3 to the power r is x to the power minus 3r, and both bases are same, so power will be added, and it will become like this. So 15 cr minus 1 to the power 15 minus r, yes, so r, it is going to be x to the power 60 minus 7r, right? So in order to get the coefficient of x to the power 15 or 32, so this should be 32, right? So this should be 32. So put 60 minus 7r as 32 and get the value of r. So it is going to be 60 minus 32, I guess 28, right? So this will cancel out, and the value of r is going to be 4. So the fifth term, if you substitute r equals to 4 over here, the fifth term is the, so they sometimes ask which term having the coefficient is containing x to the power 32. So if they ask like this, so the fifth term will be the term that have the x to the power 32, right? And the coefficient, for coefficient just substitute r equals to 4 over here. So 15c4 and minus 1 to the power, this is going to be the same, so the answer should be 15c4. Okay, so the option C is the answer. Next is question number 12. In the expansion of this, so it is also easy. In the expansion of this, the 12th one, you have to find the term which is independent of x. The term which is independent of x. So that is going to be 3x square upon 3x square upon 2 minus 1 upon 3x to the power 9. So in the expansion of this, you have to find the term which is independent of x. So what you can do, let's say this one is the term which is independent of x. So pr plus 1 is going to be ncr. ncr means 9cr. 3x square by 2 to the power n minus r means 9 minus r, and this is going to be minus 1 from 3x to the power r. Now so yeah, just pay attention over here. While solving the means you calculation part, so you have to be very careful about this, right? 3f by 2, I'm separating the constant term, so it is going to be 9 minus r multiplied with x square. So x square will also get the power n minus 9 minus r, and for here minus 1 to the power r, and and minus 1 upon 3. I can write it like this, right? Minus 1 upon 3 into 1 upon x, and 1 upon x can be written as x to the power minus 1. So x to the power minus 1 into r. So this is how you can separate the terms, right? So this can be written as 3 by 2 into x square, and each will get the power this. So 3 by 2 to the power n minus r, 9 minus r, and x square to the power 9 minus r. For here also it can be written as minus 1 upon 3 into 1 upon x. So minus 1 upon 3 to the power r, and x to 1 upon x is x to the power minus 1. So that is like this. So if I separate the constant term side, so this is going to be 3 to the power n, 9 minus r, and minus 1 upon 3 to the power r, and these terms can be written 2 x square to the power this, so x to the power 18 minus 2r, and here it is x to the power minus r. For this part, right, it will become x to the power 18 minus 3r. Okay, so 18 minus 3r is equals to 0. So 3r equals to 18. So r is equals to 6. So when r is equals to 6, this why we have put in 18 minus 3r equals to 0, because when x to the power 0, then it will become a constant term. So r equals to 6. So the seventh term will be the term which is independent of x, and so put r equals to 6 over here, right? So 9c6 into 3 upon 2 to the power 9 minus 6 is 3, and minus 1 to the 1 by 3 to the power r is 6. Okay, so this is how you can do this. So 9c3 3 by 2. So whatever you can simplify, and you can get the answer. Okay.